Okay, continuing on with chapter 2, we're moving on to section 2.3, properties of functions. Okay. So there are a good number of objectives in this section, so this is going to be split up into several videos. So we want to identify from a graph what it means for a function to be even and odd, but we also want to be able to do that through an equation. Okay, so we want to be able to identify where a function is increasing or decreasing or constant. We want to find local maxes and local mins. This is where a function is the biggest or smallest it can be. We want to find absolute maxes and mins. So there's going to be a difference between what a local and absolute maximum is. We want to use graphing utilities to approximate where these occur, and we want to find average rates of change of functions. So there's a bunch to get through, so let's go ahead and get started. What is an even function? So back in section 2.1, where we were just learning about function notations, we computed things like what's f of minus x. Now there are some functions where f of minus x and f of x will be exactly the same, and that's what it means for a function to be even. On the other hand, if you compute f of minus x and you also compute minus f of x, and those happen to be exactly the same, that's what it means to be odd. There are functions that are neither even nor odd. Okay? In the example we did in section 2.1, f of minus x was definitely not the same thing as f of x, but it also was not the same thing as minus f of x. So it was neither even nor odd. If f of minus x is the same as f of x, we call that even. If f of minus x is minus f of x, we call that odd. It's possible for functions to not do either thing. Okay. Now, even and odd functions are very related to graph symmetry, which we discussed in an earlier video back in chapter 1. Okay? If the function is symmetric across the y-axis, the function is even. And if the function is odd, it's symmetric across the origin. Okay? There are no functions that are symmetric across the x-axis. Those would fail the vertical line test. They wouldn't be functions. But if you're symmetric across the y-axis, you are even. If you're symmetric across the origin, you are odd. Okay, so an example. Is this a graph of an even function, an odd function, or a function that's neither even nor odd? It's not even a function, so it's symmetric with respect to the, it is not symmetric across the y-axis, it's not symmetric across the origin, so it's neither even nor odd. It's actually not even a function because it fails the vertical line test. There are plenty of vertical lines that intersect more than once. How about these? Again, are they even? Are they odd? Are they neither? Are they not even functions? I'll pause. Okay, so this function over here is even. It is symmetric across the y-axis. It's even. And this function is odd because it is symmetric across the origin. All right, how about not from a graph, but algebraically? Can I determine whether a given function is even or odd? There's 4 here, so how are you going to do this? You're going to take the function and you're going to ask, so for example for a, is f of minus x equal to f of x? Or is it equal to minus f of x? Or is it equal to neither? That's what you have to do. Plug in minus x, compare to the original function, to minus the original function, and see if they're the same, or maybe they just aren't. So I'll pause here while you work through the 4 examples. Determine whether these 4 functions are even, odd, or neither. Okay, 2x squared plus 3 is even. If you plug in negative x, once you square it, it doesn't matter. So f of minus x is the same thing as f of x. It is not the same thing as minus f of x, so it was an even function. Sorry. B, if I replace x with minus x, I get negative x cubed plus 3, but that's not the same thing as g of x, okay? Because I have this minus sign here. But it's also not the same thing as minus g of x, because that would give me a minus 3 here, which I didn't get. So this is neither even nor odd. Okay? It's not symmetric across the y-axis. It's also not symmetric across the origin. Example C, if I replace x with minus x, I end up with a minus sign in front of both terms, which is the same thing as if I had just multiplied the entire function by minus 1. So this is an odd function. It is symmetric across the origin. And finally, for the last one, the only thing going on with x is this absolute value. which doesn't care about the plus or minus. So this is actually an even function. Plugging in minus x and plugging in x will get you the same result. This is an even function. It's symmetric across the y-axis. Okay. So I will pause here. I'll split this video and start the next one to talk about increasing and decreasing functions.